Welcome to This Explainer, everyone. Today, we're diving into an absolute game-changer in healthcare data, backward-generated case and cohort intelligence for clinical audits and research. Now, for decades, the medical field has relied on a very specific, traditional way of asking questions about patient data. But today, we're going to look at a fundamentally new approach that flips the script entirely. We're literally rethinking how clinical audits and research are conducted from the ground up, simply by changing the direction we look at the timeline.
Think about it. What if the best way to figure out what went wrong is to actually start at the end and hit rewind? We're going to play detective today. We'll explore how starting at a clinical outcome and hitting rewind can uncover life-saving insights that no one even thought to ask about. It's a massive shift from trying to predict what might happen to deeply understanding what just did.
All right, let's look at the current status quo, which relies heavily on forward-directed querying. In the traditional forward method, a human has to first come up with a hypothesis, turn that into a database query, and then check the patient records to either confirm or deny it. It's a lot of manual guesswork. But the backward generation model, it moves in reverse. It takes an outcome that has already happened, replays the timeline, and actually uses that data to formulate the question for you.
And here's why that distinction is absolutely vital. Forward-directed systems only find what we already know to look for. They're just checking compliance against pre-written rules, one chart at a time. Now, forward audits work incredibly well if you already know exactly what to suspect. Like, say, if you want to know if a specific antibiotic was given within a 4-hour window. Perfect. But they fail completely when the crucial signal is something nobody hypothesized in the first place. I mean, you can't query what you don't even know to look for, right?
So that brings us to the solution, backward-generated intelligence. This system takes a realized outcome as the seed, reconstructs the coded events that preceded it, and finds recurring patterns across a cohort to generate candidate audit questions. Basically, we let the pipeline walk backward through standardized medical records, specifically those coded FHIR and SNOMED CT timelines, to generate the questions for us. The system's entire job is filtering, ordering, and comparing those items against a baseline, which completely bypasses the need for a human to guess the root cause beforehand. Section 1. The micro-investigation, replaying the patient timeline.
Let's zoom in on a single patient's backward trace. Think of this as our scene of the crime. Imagine an automated investigator scrolling backward from an ICU escalation on day 0. Moving back in time, the system uncovers a missed vital trend on day -1, where no intervention was logged. By day -5, it flags a medication switch to a second-line agent. And all the way back on day -14, it notes a pre-existing comorbidity that was already on the patient's problem list. It's essentially a reverse chart review, assembling the exact chronological evidence trail leading up to the crash.
Sure, humans can do this manually, but it takes immense time and effort. Computers, on the other hand, are perfectly happy doing this unglamorous reverse chart review. They don't need coffee breaks. The pipeline handles all the heavy lifting of scrolling, tagging clinical lanes, and templating questions based on data that's already pulled. It turns raw timeline events into specific, query-backed candidate questions. Something like, was that vital sign trend on day -1 actually acted on, or was it merely recorded?
Moving on to Section 2, the macro investigation, discovering cohort-level lift.
Now, a single backward trace is just an anecdote, right? But what happens when we zoom out and run this replay across every single patient sharing that outcome? Well, the system pools these coded items into frequency tables, instantly doing the math an epidemiologist would normally run by hand. We can see how it breaks down escalation rates within groups, comparing patients with chronic kidney disease, type 2 diabetes, and COPD against a baseline of patients with no flagged comorbidity. The pipeline automatically calculates the ratio against that baseline, instantly surfacing which pre-existing conditions are most highly correlated with the negative outcome.
And there it is. The crucial point is this massive 2.4 times lift for patients with chronic kidney disease. This is a vital statistical trend triggered completely automatically by the seed outcome. Nobody had to write a pre-registered hypothesis guessing that chronic kidney disease might be a factor. The data just surfaced it independently. It tells a reviewer or a researcher exactly where a design study might actually be worth running.
Section 3. Real-world architecture, building the evidence trail. So how do we actually build this? Let's break down the exact real-world architecture required to turn these raw outcomes into actionable clinical intelligence. It walks through 5 specific steps. First, it starts by taking the seed outcome. Second, it traces it back to pull all coded items in a look-back window. Third, it rolls up that reverse chronology across a cohort.
Fourth, it compares those pooled frequencies to baselines to compute lift. And finally, Step 5 produces a ranked finding. What's truly brilliant about Step 5 is that the audit artifact includes the exact auto-generated SQL or ECL query. That means a reviewer can independently rerun the attached query against the source records and verify the exact same table.
And guys, this isn't just theoretical. This pipeline powers everything from automatically drafting what led up to this reports for retrospective quality reviews to finding hidden justification gaps for denied claims. It can literally trace a 30-day readmission backward to find common threads and discharge windows. For pharmacovigilance, it surfaces pre-event medication changes that recur across adverse drug event reports. It provides a reproducible shortlist of candidate exposures before any funding is even committed to a formal study design. It's a real game changer.
Section 4. The human element. Crucial guardrails for reviewers.
Okay, as powerful as this detective work is, we absolutely must discuss guardrails. We have to keep this grounded in reality. First off, we must remember this system only looks at coded data. If a hallway conversation, an unlogged clinical judgment call, or a missing chart note wasn't coded, well, it's not in the trace. The absence of a finding is not evidence of absence. Furthermore, it provides correlation, not causation, so confounding variables are totally to be expected. And importantly, it surfaces observed historical rates. It is completely illustrative and should never ever be treated as a validated predictive risk model.
I love this quote from the source because it hits the nail right on the head. Not a conclusion, a lead. A human in the loop is absolutely mandatory here because the system generates leads, not final verdicts. Every artifact is essentially a highly qualified candidate question for a reviewer. The templates exist to standardize how that lead is presented to the medical committee, but it never replaces the judgment of the professional who actually has to decide what to do with it.
As we wrap up this explainer, I want to leave you with this thought. How much hidden knowledge is trapped in our clinical records right now, just waiting for us to look at it in reverse? What life-saving insights, actionable patterns, and critical missing links are sitting in your data today simply because you haven't hit rewind? The answers are already in the timeline. We just need to change the way we look for them. Thanks for joining me, and I hope this sparks some backward thinking in your own clinical data journeys.